Hi, my name is Shad Hufnagel. I'm the Forest Health Coordinator with the Kansas Forest Service, and today we are going to examine and discuss different treatment options for emerald ash borer, a invasive, devastating, or damaging, destructive uh, wood-boring beetle that is attacking and killing ash trees throughout a good part of the United States, including Kansas, where as of 2025, we have 18 counties with known infestations of the insect, um, three detections in 2025 alone. And as EAB moves into new areas, we feel it's important to have information and resources available to folks, communities, and landowners and homeowners alike, so that we can better assist in providing opportunity and resources to navigate the decision-making process, identify appropriate responses for emerald ash borer, as well as examine different treatment options to help minimize some of the damages and negative implications resulting from emerald ash borer and its feeding. So to optimize viewing of the presentation, I'm going to go ahead and minimize my screen so we can see the presentation in its entirety. And so for starters, I felt it was appropriate to take a first look at what we mean when we say treatment. And according to Merriam-Webster, treatment has many different definitions, including a few of which I felt were that felt aligned really well with the topic of EAB and the damage that it causes. Those being the action or manner of dealing with something, and also the management and care to prevent, cure, ameliorate, or slow the progression of a condition. And so the condition here being the damage that EAB and its feeding causes. And so when we look at how to approach or deal with EAB, there's a few key components that we'll look at and consider that will help with hopefully the decision-making process, and then looking at different treatment options, those being prevention, detection, response, and expectations. We'll take a closer look at each of these, but prevention is probably more accurately described as hindering the spread or slowing the spread and damage of EAB. It's unfortunate because if ash trees are present, EAB either is or likely will be at some point. Detection is another key component. Early detection is key, and we'll look how it's important, but how it's also difficult. Response, what action is taken, and then what's appropriate, what's an appropriate level of action, and that can range from removal of ash trees. It can also the initiation of chemical insecticide treatment to help protect certain ash tree specimens, and possibly the appropriate response might not to be taking any action at all, depending on certain conditions and situations. So what are our expectations? Are they reasonable? Are they realistic? Just making sure that our expectations are aligned with what reality will likely present. So prevention is probably more, again, about just slowing the spread of EAB and the damage that it causes, as opposed to actually preventing it altogether. Ash trees are native to Kansas, and so we'll find ash trees in our rural forests, riparian areas, as well as a commercially planted tree in our urban settings, due to their popularity for decades as their aesthetic value, and some of their being just visually appealing. And so one thing that's important in the effort to slow or hinder EAB and its impacts are to just learn to identify ash trees. In Kansas, we have white and green ash. and others, but those are the most common. And they are both, unfortunately, highly susceptible to infestations. Um, these can be found in again, our rural forests and riparian areas, as well as in our urban landscapes. And so as far as identification goes, you can see an image here of a medium, moderate sized ash tree, kind of that rounded open growth habit. And then the new foliage being a little, relatively lighter green than the more established foliage. But the next image over does show like that glabrous shiny leaf, the lanceolate leaf shape, as well as the fine, small serrations along the leaf margins. Beneath that, you can see the opposite branching habit that is a characteristic of ash trees as well as other tree species, but ash is one of those. And then the far right image, you can see the kind of the furrows, those ridges, elevated areas and those depressed areas forming diamond-shaped patterns in the bark. And then typically those that diamond-shaped pattern or look will become more prevalent and pronounced with age. But you can kind of see that beginning to form on this smaller specimen image of bark there. And so promoting and maintaining healthy trees. Just as mentioned, it's unfortunate ash trees that are unhealthy and in a susceptible state are prone to EAB infestation and attack, but they will also attack and kill perfectly healthy specimens as well. So the advantage we have with healthy ash trees is that it might actually take a little longer for the trees to succumb and then eventually become hazardous during or after the infestations. And so this extra time can be helpful and be resourceful as it provides opportunities for other measures of response. And then where feasible, like in urban areas or landscapes, it's helpful to make sure that trees are adequately watered and protected from damage that could potentially weaken them or make them more susceptible to other stressors. Not likely something that we can achieve on a larger scale in our natural woodlands and forests, but in a residential and urban settings may be a possibility. Another just important consideration is the potential removal of unhealthy ash trees. It may be wise to have unhealthy ash trees removed prior to them becoming hazardous or prior to like larger, more widespread removal efforts when those things need to take place. That way it doesn't all have to happen in a short amount of time. And so when inspecting ash trees and their condition, it's also important to just inventory for other tree species and see what other tree species are present. Just as a general rule, in an effort to promote forest resiliency and ensure future canopies, it's worth investing in diversified tree plantings. So when species-specific pests like the emerald ash borer move into an area and destroy a certain tree species, it's important to have other tree species present as well that will remain unharmed and present in our landscapes. And then finally, we all remember the Don't Move Firewood slogan and campaign. That certainly holds true in this case. While EAB does travel naturally, to find host trees on which to feed and lay eggs, it just generally only moves as far as it's needed to find a food source. And oftentimes that means they'll find a tree immediately adjacent to where they are, or perhaps even continue to feed on existing host trees. So natural spread from emerald ash borer is generally fairly slow. However, moving firewood or other wood products can quickly increase the spread and presence of emerald ash borer as other insects and pathogens into areas where they weren't already present. So by using and buying local firewood, we can help reduce the spread of EAB. And there in the bottom right-hand image is some downed ash material a wood material that was sourced nearby. In fact, just off the right side of the image was the tree that the branches came out of, and then in the distance there you can see a picnic table and maybe a fire ring there. So they have kept that firewood on site. Detection, as mentioned, early detection is difficult, but it's important. And why is it difficult? Well, because newly infested trees often show few symptoms. In fact, it's just not unusual at all for trees to be infested for multiple seasons before the tree will exhibit any outward or real distinct detectable visual signs of stress or decline. One way to stay up to date on the presence of EAB detections is to check out the Kansas Forest Service website listed there on your screen. And KFS maintains a map that reflects the current known range of EAB within the state. And as you can see, as of 2025, we have 18 counties confirmed. 3 of those were confirmed just this year, those being Pottawatomie County, Lynn, and Bourbon counties. In addition to this map, the Kansas Forest Service also shares social media posts when new detections are confirmed. And then we also have Kansas Canopy newsletter, which can be found on our website, which is a great resource for information and content pertaining to KFS activities and happenings, as well as tree-related information and EAB detections. The Kansas Department of Agriculture, they maintain a similar map and information pertaining to the presence and spread of emerald ash borer. And so the Kansas Forest Service, along with partners, recognizes the importance of early detection and has for many years utilized trap trees to assist with detections. And trap trees are essentially intentionally girdled ash trees intended to promote stress in the tree, and then therefore making that tree more appealing and susceptible to EAB infestations. The trap trees are typically installed in spring prior to adult emergence. And again, that would allow for emerald ash borer seeking host trees to seek these trees that are stressed as host trees. And then later in the fall, the trees are felled, peeled, and then carefully examined for insect specimens. We work with KDA on this and for confirmation of these physical specimens that are found. And so you can see in the images there on the bottom right, there is a sign being installed on a trap tree. And that sign just shares information on emerald ash borer itself and what the purpose of that trap tree is. The next image over is just some downed ash material that's been peeled in an effort to find physical specimens of the insect, like the ones seen on the right, where in the same image we were able to capture a larva and an adult insect in the same image. And so in 2025, we have placed detection trees or trap trees in 11 counties that are adjacent to counties with known EAB infestations. And in addition to the utilization of trap trees, we also look for other signs and symptoms of EAB. Some of these identifiers would include like canopy dieback. And so you can see an image of an ash tree with a greatly reduced, the foliage greatly reduced in the canopy, indicative of some sort of decline within the tree as the insect activity moves from top to bottom. And then you'll also see some of that epicormic growth in the form of water sprouts and suckers that's usually indicative that the tree is undergoing some level of stress. In later stages, it's not unusual to see like bark splitting and cracking might be observed as well. And then we could look at exit holes, D-shaped exit holes from where the adults emerge from the host trees. The very distinct D shape is reflective of flat-headed borers, of which emerald ash borer is one. And then also you can see blonding or flecking, or some people call it woodpeckering, of ash bark in that top right photo. That's essentially caused by woodpeckers searching for and feeding on larvae beneath the bark. So they will, in an effort to consume them, they will remove pieces of bark, exposing and revealing that lighter color underneath. We'll also look for feeding tunnels, galleries, where you'll see these S-shaped or serpentine-like feeding tunnels or galleries that are often also have frass, or this kind of sawdust-like material that's essentially the feedings or the insect excrement. And then finally, we'll also be looking for adult insects, and so or physical specimens, including adult insects. And so you'll see an adult emerald ash borer, and there are lookalikes out there, but there is that metallic kind of emerald green color that is associated with adult EAB in relative small size. And then also there is a larva there where you have that distinct bell-shaped body segments. When considering what's an appropriate response to EAB, it's not always black and white. There's some general guidelines that can help determine what to do and when to take action. And generally speaking, the recommendation is to delay chemical treatment of ash trees until EAB is known to occur within 10 to 15 miles of your tree or within your community or county. Some resources might suggest a range of up to 30 miles of your tree, county, or community. And I do know there are cases where people have made a personal decision to begin chemically treating ash trees well in advance of these thresholds, and just as a decision to provide protection for their trees as long as it is under their care. But again, just emphasizing that EAB will typically travel only as far as needed to find a suitable host. And so just to ensure that there's, efficient use of product and then treatments that are actually going to be providing some level of protection. And then aside from location, there's a few other questions to consider when navigating the decision-making process, including do you have ash trees? Do they have site or sentimental value? Are they healthy and in a good condition? Do you want to save them? Do you have funding to save them? And if the answer to any of those questions is no, you will likely not be seeking protections, in the form of insecticide applications. But if you answer yes to these questions, we can move on to the next consideration, which is what is the diameter breast height, or DBH, of the tree. And so this can be determined by a couple of different formulas, one of which is taking the circumference in inches at the tree 4.5 feet above the ground, and then divide by 3.14, or alternatively multiplying the circumference in inches of the tree by 0.32. Both of these formulas will result in the DBH of the tree. So trees with a DBH of 15 to 20 inches or greater would require professional insecticide treatment as the only options available for trees of that size. Trees that have a smaller DBH, and the smaller the better, but in the range of less than 15 to 20 inches, can either be treated using any of the professional insecticide treatment options that we'll discuss, but also potentially a soil drench, which is the only homeowner option available, and we will look at those further. But first, what constitutes a healthy, good condition ash tree? And so trees with a 30% or greater canopy loss are generally not recommended for treatment. They're just not good candidates for a few reasons. One is they'll just too much dead material within the canopy of the tree, and too much compromised vascular system, and rendering the results ineffective, essentially. So there's a really great image here that we use as a visual reference for what crown thinning might look like. And so on these three images, starting at the right, there's an ash tree with a canopy loss of about 50%. Then we have a tree in the center with an ash tree with a canopy loss of about 30%. And then the tree on the left is more indicative of a tree canopy with only 10% thinning having occurred. So any tree with that is visually best represented by that center tree with a 30% thin canopy or greater are not going to be good candidates for insecticide treatment. And then what about trees that are currently infested with EAB? Well, they can still be treated, but early detection and treatment is imperative for success. And so that is, again, because any damage that is existing will not be reversed or fixed by the insecticide treatments. And then there's still going to be some level of vascular system damage and potentially, compromised structure and just reduced health and vigor of the tree. The results may be less than desirable. So insecticide treatments are the chemical treatment of ash trees and the prevention of EAB. And the primary application methods include trunk injections, canopy sprays, trunk sprays, and then soil applications in the form of a soil injection or a soil drench. And of these options, the only homeowner option available is the soil drench. It can be applied by a homeowner or a professional. All other options, including soil injection, are applied by professionals only. So regardless of the application method, insecticide treatments require proper preparation, dosage, and timing for effective, safe, and successful results. Homeowners and professionals alike must read, understand, and follow the protocols and product labels. And then it's important to understand that for proper protection and ongoing protection to take place, those treatments will need to be applied at appropriate intervals for the life of the tree as long as EAB is present. And in most cases, application intervals are between 1 and 2 years. Not all application methods listed are equally effective or environmentally responsible and sound. And then it's important to note that trees could still die. So, the use of insecticides will not protect trees from pathogens and drought and inclement weather and other possible maladies or reasons for mortality. Trunk injections are the most widely used technique for EAB treatment, and according to most research, the most effective, with emamectin benzoate being the most effective insecticide. Trunk injections are a systemic application that will need to allow time for proper uptake and distribution within the tree, and depending on the chemical, can take 1 to 4 weeks for that chemical to get distributed throughout the tree's entirety to provide adequate protection. Typical injections take place late April through June when new leaves are expanding and emerging. It's a sign that the tree has an active vascular system. For proper control and protection, earlier applications are better than later applications. And we get a little later in the season, we start to see black locust blooming. That would be what we would consider like a late trigger or kind of that bookend of the late application times. And so just trying to ensure that the trees have some level of protection prior to the adults emerging and seeking out host trees on which to lay eggs. In trunk injections, there is specialized equipment that's used by professional arborists and tree care professionals to inject an insecticide into the tree. This is typically regarded as the most costly but effective treatment option. And at time of this recording, most research I've looked at shows a cost of $10 to $15 per caliper inch at diameter breast height. And then proper treatment of these trees can and has provide 2 years of effective control, while also minimizing runoff, drift, and exposure to non-target organisms, including pollinators. Many companies offer tree injection equipment and products, in both cases, they do require either drilling a small hole through the bark into the vascular system of the tree or inserting a needle-like injection tip into the vascular system. And the larger the tree that's being protected, the more holes or insertions will be required. This process does result in some level of tree tissue injury, but as it relates to tree protection and mortality, the benefits outweigh the costs. And so trees can't compartmentalize wounds. They don't necessarily heal, but they do seal off areas of injury. And so trees can compartmentalize these small wounds. And then the insecticides are absorbed through those holes or insertion areas, and then that product is then dispersed throughout the tree and translocated throughout the tree's entirety and all the parts of the tree, providing thorough coverage. Trunk injections of insecticide can provide 2 or more years of EAB control. Single treatments of emamectin benzoate have consistently provided effective control for 2 to 3 years. And there are communities that are exploring how long of protection they can obtain through single treatments, and especially in areas where EAB populations may have been reduced. And then a factor to consider as far as the effectiveness of this application technique would be just monitoring drought and dry conditions, as they can negatively impact the uptake and the distribution within those trees. And so it's important to just consider how active the tree's vascular system is, as well as what recent weather conditions have been like. And so in the images here, you'll see a small pilot hole that's been drilled into the base of an ash tree near its flare roots. And then you'll see a little bit of that wood shavings that came out with the drill bit. But again, a fairly superficial hole that is to the base of the tree. And then the image on the right is a photo I took in Denver of a kind of a public awareness message to let citizens and folks in that area know that there's ongoing efforts to provide EAB protection to their ash trees. And so they have that ash covered. Canopy and cover sprays, as mentioned earlier, does potentially offer some level of protection, but it is generally just not recommended for EAB control for a few reasons. One of which is it's intended to serve as a contact herbicide, meaning the insecticide will have to come in contact with the insects to provide any level of control, and they will actually have to feed on, or have physical contact with that insecticide for any level of control to take place. Getting that product into large trees, large organisms on all surface areas and all the foliage is difficult. And then in an effort to do that, there would be increased concern for drift and an impact on non-target species, and trying to spray an insecticide up into a tree, or even from a bucket truck or ladder or something. There's still going to be more of a likelihood of drift with this application technique, resulting in potential for drift, an increased potential for drift anyway, and then impact on non-target species. The applications typically have to be fairly frequent to provide adequate control. And then the protection that is offered is pretty short-lived. The chemical is quickly degraded by the elements, rain and wind and sun. And so that's where there is some limiting benefits to this application technique. And so the other thing to consider is that The damaging stage of EAB's life is the larvae stage, where they are beneath the bark of a tree and feeding on the vascular system. And so these herbicides or these insecticides that are applied to the exterior of a tree are really not coming in contact with the insect, the target um, specimens, and then really not providing any control of the larvae. Trunk sprays are similar to the canopy cover sprays in that there's a insecticide applied to the lower 5 to 6 feet of the trunk. The insecticide then penetrates the bark and is absorbed into the vascular system of the tree. So not really spraying up into the canopy, or trying to get an insecticide to cover all the foliage or surface areas of the tree, but just that lower portion of the trunk. Is often considered a non-invasive systemic pesticide control due to the fact that you're not injecting or drilling holes into the bark of the tree. Dinotefuran is the most common chemical used for this application technique. There's still some concerns for drift and impact on non-target species. There's still product being applied in the elements. And so the insecticide will also be present on the treated surfaces. So those applications typically are applied annually in mid to late spring after leaf out, when the vascular system is active within these trees. And weather considerations will be something that needs to be taken into account with this, as well as the canopy and cover sprays we just discussed. Wind and rain may impact effectiveness. So making sure to get adequate coverage on the trunk, and ensuring that we didn't have rainfall event immediately preceding or immediately following the application, which would be limit the effectiveness of that technique as well. And then the trunk sprays are typically better suited for smaller tree specimens, as larger trees with thicker bark there could be some difficulty with that chemical being absorbed into the vascular system of the trees. Soil treatments, we talked about a couple of those options. The one being soil injections, which needs to be done by professionals only. And then a soil drench, which still can be provided by professionals, but it is the only homeowner option. And so on trees that are less than 20 inches diameter breast height, and I just want to emphasize that smaller specimens are better candidates, would be candidates for this treatment type. And where products like imidacloprid or dinotefuran are applied on or in the soil near the trunk of the tree, and then that product is then absorbed and translocated by the tree. Results are inconsistent, ranging from effective to ineffective, but there's a lot of variables that will come into play in that effectiveness. And so soil moisture content is one of those. There also may be restrictions on how much product can be applied per year per acre with these products, and then additional restrictions on if and how these products can be used near bodies of water. So it's imperative to become familiar with the labels and what those restrictions are with the use of this technique. So the product can be absorbed by surrounding plant material. So if there's other plant material that have a shared root zone with the treated ash tree that gets these soil drenches or injections, it is likely that they too will absorb an insecticide and carry it throughout their tissues and plant parts. With soil injections, liquid product is injected 2 to 4 inches into the soil within 1.5 feet of the trunk, where the absorption roots are of higher density. There's a little reduced runoff potential due to the product being applied in the soil instead of on the surface. But again, there needs to be considerations for soil content and moisture. So making sure that the product will be actively absorbed, and then also what is that soil content? What's that soil composition? Is it sandy soils versus clay soils? And those variables will come into play with the effectiveness of these treatments. Applications are early to late spring or mid-fall, depending on the product selected. And then the soil drench, again, the only homeowner option available is where a liquid or granular product would be applied to the soil surface, which increases exposure risk. We've got insecticides that are now essentially just sitting on top of the ground. And there would be higher runoff potential due to that. And because that, if there's, moisture or other soil content considerations, heavy rains following an event, just making sure that that product can adequately get down into the fibrous root zone of these trees that are treated, and that chemical can get actively absorbed. Imidacloprid, one of the products, the chemicals that's used for these soil drenches, can bind with surface material like mulch, leaf litter, or thatch and turf, which would then reduce uptake. Soil drenches are limited to one application per year, typically in early to mid-spring. And due to some of the potential environmental implications and concerns, it's especially important to read, understand, and comply with label and restrictions. And then biological control, or the use of living organisms like predators, parasitoids, or pathogens for pest suppression. It's not really a major control strategy for EAB at this time, but it is worth mentioning and recognizing that there are ongoing efforts to improve this control strategy. And so the parasitoids are essentially really small insects, wasps or flies that lay eggs on or in hosts, and then the larvae feed on and kill those particular hosts. Some parasitoid, there are some native parasitoids that can parasitize EAB larvae, but not necessarily seeking them out exclusively. There have been 4 species of parasitoid wasps introduced into the United States through USDA Animal and Plant Health Inspection Service, APHIS. And they are reared for release. Studies and research has shown highly variable egg and larvae control, ranging from effective to essentially ineffective. Research is still underway to improve the control and efficacy. And then anytime that a non-native or an exotic species is introduced, even if it is to control other non-native exotic pests like the emerald ash borer, there are some ecological concerns and complexities to consider. And then an environmental release permit is required for the release of these parasitoids. And then woodpeckers. Woodpeckers are the primary predators of EAB in North America. In Kansas, we have several species of woodpeckers throughout the state. They will feed on larvae from fall until spring. Highly variable larvae control. So you have native woodpeckers that are adapted to feeding on a wide array of other organisms and not just EAB. So I do think EAB larvae make the menu, but the menu has other options as well. And then a lot of times when you see significant woodpecker activity in an area where maybe woodpecker populations are high enough to provide some level of control and impact, generally it's going to be pretty late in the game when EAB populations are really high and a lot of the damage has already been sustained. Expectations, today and into the future, and what can we reasonably expect when it comes to EAB presence, problems, and treatment. Today, we know that emerald ash borer will continue to spread and infest ash trees. As mentioned earlier, if ash trees are around, so are or will be emerald ash borer. Untreated ash trees in areas where EAB is present will be killed invariably. Ash trees will need ongoing treatment for continued protection. It's not a one and done treatment. It is the treatment options that are currently available will need to be applied at appropriate intervals and likely for the life of the tree as long as emerald ash borer is present. And then professional trunk injections of ivermectin benzoate are a superior treatment option, although there are other options available. And so for tomorrow, we look toward improved technology and potentially reduced EAV populations, making, or allowing for less frequent treatments. Parasitoid populations could increase and provide more effective and more biological control. Research is underway to study genetic resistance of lingering ash, which are large mature ash trees that are present in areas where EAV infestations have been occurring, but are generally resilient or even left alone in some cases. And so there's research underway to find out if there's some genetic resistance of some of our ash trees, and also just the fact that nature finds a way. And so if you look at the image on the left, you can see in the background a dead ash tree that is essentially a snag back there that did die due to EAB activity. But in the foreground, you'll see little ash saplings emerging. And even though these saplings will also likely become host trees at some point, it's encouraging just to witness nature's relentless efforts to find balance. And so it's our hope that along with nature's ongoing relentless efforts, we can also find ways in which to help. That concludes my presentation. Once again, I'm Shad Hufnagel, Forest Health Coordinator with the Kansas Forest Service. I do appreciate your time and hope it was a good use of it. Thank you.